So 510, number 17, improper integrals. We want to look at the curve, right? And I can already see what's happening to x e to the minus 5x, right? Oh wait, do I have this? Do I have this right? I don't think I do. I think that's e to the x squared I've drawn. Let me just double check it. So I don't want to, there's nothing wrong with being absolutely sure, right? So I'm just going to graph that line again, y equals x e to the minus 5x. I think I'm wrong now. I do know my behavior over to the right is the same. So I was wrong about the curve. But I still can see what's going on, right, in the long run. I know from 0 to 1 is finite, right? Just a finite area there. I like to do y equals 1 over x squared as my my little safety to see if it's above the rest of my curve. If it is, I know I'm talking about something convergent, right? So that's another hint to me that I'm going to get something convergent, right? Now, remember, it's x to the p, and p is bigger than 1, but I like using 1 over x squared. It's an easy visual. If I use 1 over x, you can see that my 1 over x is above my 1 over x squared, right? And remember, I'm talking about from 1 to infinity here. The 1 over x diverges, right? So all I have to do is find something that is above it, and I know I'm going to get something convergent, something that converges that's above it, right? So, right, are you kind of getting the idea of what I'm saying? I'm going to look at, explore it, and see if I can even know if my answer is feasible again, right? Does this make sense at all? So, instantly I want to write this limit as a goes to infinity of the integral from 0 to a of x e to the minus 5x dx. And at this point, I can almost ignore that limit all the way to the end, right? I can ignore that limit all the way to the end and then deal with it. I'm going to put on your exam one with L'Hopital's. So look for it, right? Look for it. A lot of you answered without L'Hopital's on that one quiz probably because it's obvious, but I'm just trying to get you to be formal about it. So I want to do this piece with a shortcut, right? So I know I have a sine, I have my u, I have my dv, plus minus, I've got an x, a 1, and a 0, so I don't only need 2 lines. Remember, when I find dv, I need to put v on my very first piece. This piece right here should be v, right? That's what I want to put there. So if I have dv equals e to the minus 5x dx, I know v is minus 1/5 times the integral of minus 5 e to the minus 5x dx. I did a u sub there, right? U is negative 5x, du is negative 5 dx. So I need the negative 5, I need to cancel the negative 5. And so I get v is minus 1/5 e to the u, which is still e to the minus 5x. So some of you I saw put just dv there and then integrated, right? On one that was similar on the test. So and then I'm thinking, well, that negative 1/5 is going to happen every time I take that antiderivative. So I need a positive 1/25 e to the minus 5x for the next term. So I'm doing the limit of negative x e to the minus 5x minus 1/25 e to the minus 5x, all at a and 0. Again, I'm not even looking at my limit until I'm ready to take the limit, which is after I plug in the a. Now, I like to manipulate this. I don't like dealing with all those negatives all the time. So, but you don't have to do that, okay? So, for me, one, I can see I can take out the negative, right? And that goes right to the outside of the limit, right? Because I'm talking about a limit, I can take out any coefficient I want, factor it out, right? And then I see that I can factor out an e to the minus 5x, and then I have what? Just x plus 1/25. I like to simplify before I start plugging things in because it gets so messy. But you do what you want to do. It doesn't matter. I don't care if you hand in a messy paper, but it should all be the truth, the whole truth, and nothing but the truth, right? And then if you do start writing little side notes, you know, you can always box it off and say, Robert, don't grade this. That's what that says to me. Don't look at this, right? So remember, I'm going to do evaluate at a, subtract evaluate at 0. But I see that I'm starting with a negative, so I'm going to evaluate at 0, right, first, and that negative will go away, and then evaluate at a with the negative, right? Does that make sense? I'm going to evaluate at 0 first, right? So that's e to the minus 5 times 0 plus 1/25. Well, that was supposed to be second, so the negative canceled, right? And now, because I don't have an a in there, I don't need a limit on that, right? So now, minus the limit as a goes to infinity of e to the minus 5a times a plus 1/25. Is that making sense? I'm probably confusing some of you, but do what you want. This stuff is, the calculus is done here until I take the limit, and that's even Calc 1, right? So you do it how you want to do it. But I know if I kept the signs going, I would have 3 more lines than what I just wrote, right? But again, doesn't matter to me. So what do I have here? E to the 0 is 1, so I have 1/25 minus the limit as a goes to infinity of e to the minus 5a times a plus 1/25. So I have to think about this now, because this is where L'Hopital's is going to come into play. What happens to e to the minus 5a? As a goes to infinity, goes to 0, right? It's actually that curve, but it's okay. And then what happens to infinity plus 1/25? That goes to infinity. So I have a 0 times infinity here. And when I have that, I need to manipulate it. Take one function, make it a reciprocal, and put it down in the denominator. And it's usually the easier one to do. So for example, if I have an ln, what does the inverse of ln look like? Right? I'm not inverse, reciprocal. Ln to the minus 1 power? Oh, no. So you should trust your instincts on it. You might have to try both, right? But it should be obvious. This one is obvious because it's, when I move that e to the minus 5a downstairs, it just becomes e to the 5a, right? And now I've got an infinity over infinity. Do you agree with that? As a goes to infinity, infinity plus 1/25 is still infinite. E to the 5a is an increasing function. It goes to infinity. So I have infinity over infinity. That's what I want for L'Hopital's rule, right? So I'll say hop and limit as a goes to infinity of the derivative, right, over the derivative. I ask my students to write that in Calc 1. I don't care if you write that now. You can just go right to your derivative, right? So what do I get? 1 over 5 e to the 5a. Well, now the downstairs is going to infinity. 1 divided by infinity is going to 0, right? So there it is. So this piece is 0. So yeah, I mean, pretty wordy, like, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines of writing, plus a little side work, right? I mean, it's annoying. Get over it, right? It's annoying to play Monopoly. Does anybody not know Monopoly? This game where you buy.
Someone plays Monopoly.
But it's annoying. Are you going to sit there and be annoyed with your nieces and nephews, or no? You're going to be the banker and steal money and then see if you can't get caught, right? Make it fun. That's what I'm saying. It's annoying, but make it fun. Make the process right on your formula sheet. Process. What do I have to do? What should I look out for? Right? Say again? Yes. So, and you don't have to do, so let's say we went back to here, because that's kind of the original setup. I did my by parts. I'm ready to evaluate, right? So if I evaluate here, I'm going to get the limit as a goes to infinity. Again, that limit is hanging out. I'm going to put minus a e to the minus 5a minus 1 over 25 e to the minus 5a minus, now put in the 0, negative 0 e to the minus 5 times 0 minus 1/25 e to the minus 5 times 0. And I'm just saying it's, so by the way, but this piece doesn't need a limit, right? Because there's no a involved in it. And look at what that piece is. Well, this is gone, right? E to the 0 is 1, negative, so that's my 1/25th. And then I still have the limit of this negative a e to the minus 5a minus 1 over 25 e to the minus 5a. So I'm just cleaning it up as I do it. You don't have to do it. If it's going to confuse you, or if it's going to make you're going to make a mistake, don't do it that way. Yeah. Yeah. Yeah, I know I'm getting an f of, right? F of b minus f of a when I do an integral, right? The integral of f prime of x dx from a to b is f of b minus f of a. So I'm just picking which one I want to evaluate first. Yeah. So I mean, you got to pace yourself for this test on studying. Let me do a couple of improper integrals until I get one that's L'Hopital's. And guess what? They're later. When are you going to see a L'Hopital needed? When you see x times a ln, or x times an e, or some kind of thing that's going to go to infinity to the right and go to 0 is really what you're looking for. Or like x ln of x at 0, or x squared ln of x at 0. All of those things will kind of play out. Even this one, right, of just ln of x. Because by parts, do you have this memorized by parts yet? And x ln of x minus x. The x ln of x piece is going to need L'Hopital's as x goes to 0. So you just look, I mean, why won't I need it for x sine x or x cos x? Because sine and cos x are constantly doing this, right? So I already know that limit's an oscillator, right? Um, and then what's going to happen when yeah, no, maybe not.
But it's tough for me to identify when something is going to infinity than when like A is not going to.
Yes, yes, and so, but you don't want to, you have to stop for a second and go, well, where is this thing going, right? Where is it going? And certainly a good way to think about it is to graph each one individually. If I graph y equals a plus x plus 1 over 25, I'll see a line going up to infinity. If I graph e to the minus 5x, I'll see an exponential going to 0, right? So take your time when you get there and think about it. Yeah. I mean, you do what you are comfortable with. For me, I'm always interested in what does each piece look like, and then if I multiply them together, what does it look like? So then I could put the whole thing in, right? And what do I see when I put the whole thing in? I see it going to 0, right? Kind of like what happened right at the very beginning, x e to the minus 5x. Right? What is this 1 plus 25? Adding 1 over 25, it doesn't do much, right? This doesn't do much here. So it's really similar to the very first function. Nice, what else can I do?
Well, it's kind of a stupid question.
Yeah.
When you say goes to infinity, like you mean like it doesn't ever cross that touch.
So we're talking about this same little section I'm on here in the green box?
Well, like the graph.
Yeah. So when I'm talking about limits, I'm talking about the height of the function, right? So if I'm looking at that original red, you can see pretty quickly it's hitting the axis. It's getting closer and closer to the axis. It's hard to see it, but it is above the axis. The blue is my 1 over x squared, right? The green is my 1 over x. That one I know diverges, right? But the other ones are smaller. But the key is 1 over x squared converges, so I know that, right? So, but then I'm trying to do this limit, trying to think if I need L'Hopital's, right? I'm going y equals x plus 1 over 25. And let me get rid of my other pieces here. I mean, where is it going? Forget it. It's going up forever and ever. I know how that behaves. I don't have to. Remember Calc 1, we had to plug in numbers and see if plug in 10, plug in 100, plug in 1,000, plug in, right? And we saw it was going forever, right? But we don't, I mean, we're past that now. We know where this thing goes. But my next function, right, y equals e to the minus 5x, right? I mean, look at that thing, right? What's getting closer to their end destination compared to each other? Is the x getting to infinity faster or slower than the e getting to 0? And I would say instantly the e getting to the 0 almost happens right away. So I know what's really dominating in the function. I know what's taking over control of it, right? And so the way I can see that really is I do just like the function in the problem says, multiply them together, right? E to the minus 5x times x plus 1 over 25. And look at it. It got to 0 almost quicker than e to the minus 5x did. Right? The red one is the newest one, yeah. So, I mean, I know there's some of us that hate graphs. Some of us don't like the graphs, but I'm telling you, uh, if you could just think about the graph as the x's are me moving to the right and the height is me getting my limit, right? All these are pretty easy to think about if you graph them quickly. You don't have to. You absolutely don't have to, right? For those of us that have, like I'm ADD, if we have a little bit of a weakness in our learning style, then we've been dealing with it for as long as we've had, and we have our little cheat ways to think about things, and that's fine. Do those, right? There's nothing wrong with that. But just when you're writing the the formal argument down, I want to see all those pieces. I want to see that you caught the L'Hopital's, right? Anything else you want me to do? Nice. We got one last thing to do today, which is easy, very, very easy. So we're going to have a shorter class today.